Factorising the difference of two squares. To start off, we're just going to look at this binomial expansion. X plus 3 times x minus 3. So we've got the same bracket here, but we've only changed the plus and the minus. Let's expand it out and see what happens. So we're going to go this times this, this times this, and this times this, and this times this. So x times x is x squared. X times minus 3 is minus 3x. 3 times x is positive 3x. And 3 times minus 3 is minus 9. We can simplify our middle terms. Minus 3x plus 3x is going to be 0. And we're just going to be left with x squared minus 9. And this is a special result because when we have two binomials that we're multiplying together and all that's different about them is the sign in the middle terms always cancel out and we're left with this result. So we can generalize this by saying that if we have something squared minus something else squared, we can factorize it being the square root of the first thing plus the square root of the second thing times the square root of the first thing minus the square root of the second thing. So let's use this to our advantage to factorize things really quickly. What if we have x squared minus 16? So special note, this only works when we have a minus in between two perfect squares. Remember, this title is called the difference of two perfect squares, and difference means subtraction. So to factorize this really quickly, we recognize that it's the difference of two perfect squares. So we can write two brackets, then we square root each thing. So the square root of x squared is x. The square root of 16 is 4. And we put a plus in one and a minus in the other. And we factorize it really, really quickly. What if it was 4x squared minus y squared? Well, we can still do it because everything is a perfect square. 4 is a perfect square because its square root is 2. X squared is a perfect square because its square root is x. And y squared is a perfect square because its square root is y. So we can factorize this really quickly by writing two pairs of brackets. We square root everything here. The square root of 4 is 2. The square root of x squared is x. The square root of y squared is y. We copy that over in the other bracket. Write a plus in one and a minus in the other. What about 9x squared minus 16y squared? Well, again, we can still do it because everything is a perfect square. 9 is, because the square root of 9 is 3, and same with all the other terms. So let's go ahead and factorize that really quickly. We write two brackets. We square root everything. Square root of 9 is 3. Square root of x squared is x. Square root of 16 is 4. And the square root of y squared is y. Copy that over in the other bracket. Plus in one, minus in the other. It actually doesn't matter if you write the minus in the first one and the plus in the second one, because it's multiplication and it doesn't matter about the order which you multiply things. Let's have a look at two more trickier examples. X squared minus 5. Well, this isn't the difference of two perfect squares. X squared is a perfect square, but 5 isn't, because the square root of 5 is not a nice number. But we can still cheat a little bit and use the difference of two squares to factorize this, because we can follow the same rules. The square root of x squared is x, and the square root of 5 is just the square root of 5. And we write a plus in one and a minus in the other. Not nice looking, but we can still do it. What about x plus 3 squared minus 4? This is a tricky one to see, but we do have a perfect squared in this first term because it's something squared. And here, that's 2 squared. So here I'm actually going to write some big brackets multiplied by each other. And then the square root of x plus 3 all squared is just x plus 3. I'll write it in its own bracket. And the square root of 4 is 2. Copy that over in the other one, so x plus 3 and 2. Make one a plus and one a minus. So hopefully you can see that the square root of x plus 3 all squared is just x plus 3. Just like the square root of x squared is x, we just get rid of the square. We just get rid of the square. But here, we can tidy this up a little bit, because in here, we've just got x plus 3 plus 2. So we can add the 3 and the 2 together to make 5. And in the other one, we've got x plus 3 minus 2. So plus 3 minus 2 is 1. And that's factorized.